Okay, good morning. Uh, so I'm Mohammed. I think we know each other. It is hard for me to concentrate when there are few listeners. Let's see. Uh, I My office is here in Shinkar, 401. My email is rew@tauex.tau.ac.il. Don't seek Mohammed Arrow in the university servers or whatsoever. You will find Mohammed Arrow. That's not me. Uh, this is me. And you can send me emails whatever whenever you want, and I'll be. Let's say we can sit whenever you want. Sunday, Monday, Tuesday, Thursday. Uh, Not Wednesday, I think, but you can ask me to meet in Zoom also. So here we will learn about numerical methods for physicists. For example, the most famous things maybe numerical derivatives, numerical integrations, and numerical solutions of partial differential equations or ordinary differential equations, and a root finding and a Fourier transform or fast Fourier transform. And most of the course will be based on Taylor series. You'll see that. But also we have to work with Python because when we do numerical approximations and when we do numerical approximations, we also know what is our error, what is the bound of our error. We have to know that. And when we do that, we do many iterations. So we use computers for that. That's why we will use Python in the course. I think you are much familiar with Python than me. I will use Python. I learned it recently, and I'll use it for tensor calculations, tensor network calculations for quantum computing. And the NumPy library is very good for that. We will talk about it. Yes. The exercises will be 20% in the game. I think you know that already. You have to submit 6 out of 10 in order to have that opportunity, and the best 6 exercises will be averaged, and that's your McGain grade. It will be 1 exercise per week, and these exercises they have theoretical parts and programming part. Except this week, you only have the programming part, and you have to submit this in 2 files zipped in 1 file. The 2 files I prefer to be PDF for the theoretical part, and Python file or Jupyter notebook file for the code. No delays except cases of sickness or reserve army, and it will be according to university rules. And I will not debug your codes. Yes. So if there is a problem with the code itself, you can Google it. Yes. I think ChatGPT is good for this already also. I talked about the submission. Okay. At the first of your code, write in notes in the code your ID number, your name, and the number of the exercise. And always add comments to the code. Yes, when you define things, always add comments for the reader to understand. Okay, and it's written here, points will be deducted for lack of comments or unsatisfactory comments. I think you'll write the comments, okay? Because the reader, it takes for him much more time to understand when there are no notes. And the version of Python we will use in this course, first of all, the approved language in this course for submitting is Python. You're not allowed to submit in another language. And we will work with version 3 and higher versions. So be sure that you have version 3. And that's it. Yes, that's it. Any questions? Okay, we have a lot of people here. Okay, so as you should know, Python is a dynamic high-level language or programming language, which means that it's much more close to the human language rather than the computer language. So that makes it very easy to work with. It makes it slower a little bit, not a little bit, maybe 100 times, but who cares? Yes, we have strong computers. Everything is fine. I think all of you have installed Python. Okay, so you go to the Python website. I write it here. No. Yes, that's it. And you download it and you work with the command line to install things. You have to check that you have the right version. So you can type Python minus or dash dash version and check that it's 3 and higher than that. Here we have Noam Levy's computer. I took his recitations and files. And you download the Jupyter notebook. You can work with any editor or notebook that you want, but the files that I will put in Moodle, they will be in Jupyter, and it's much easier for you to work with Jupyter. But you can work with anything you want. And that's how Jupyter looks like when you open it. Any questions? You all have that already? Yes. Just the browser. Yes, it will be open on the browser. You'll have it on your computer, but it will be open on the browser. Okay, so today it's dedicated for a baseline of Python for all of us. And what you have here is sufficient for this course. I think most of you took the last year computers for physicists, something like that. But if you didn't take that course, you can check here, and I think you can finish this in one day. And this recitation also, it covers all we want for the course, maybe much more. And if you want to work with Python in research, for example, or to work in the work, I prefer for you to read a book or to read an internet source, because when you work with a language, you have to understand how it works internally also. That will make it easier for you to to develop things. And again, always you can ask Google or Stack Exchange for your errors. And most of the time, 99.999% of the cases, your error or your problem or your trouble in the code, someone else has that problem, had that problem also. So you'll find it. And we'll start with basic data types. So the variables that we can use in Python, there are many variables, but we'll use integers, floats, which are numbers, and booleans, and strings. So let's start with numbers. You can define number. You'll see, I think you've seen that before. The language here is like our language, yes. So I can define a variable x equals 3, and I can print the type of that variable, and the type will be printed to be integer. I can add, I can subtract, can multiply, divide, and I can exponentiate. The exponentiation is star star, not like this, not this. And if you want to increase x by a number, you write or you type x plus equals that number, and that will take x, add to it that number, and reassign the value of x. And you can do that not only with plus, you can do that with product and subtraction and division. And exponentiation also. And when we wrote x equals 3, it immediately interpreted by the by Python to be integer, because Python is efficient. But when we write 3 point something, it's like here, it no longer can be interpreted as integer, so it goes to float. You see, and we can print many things together. When you have this comma, it will be translated in the print function to a space. Yes, so print y and +1 and multiplication by 2. So we have this space here. Okay. And you don't have the x plus plus. Yes, you have plus equals and not the plus plus. Yes.
Keep quotation marks around the word and.
Here?
Yeah.
No, you want this and okay.
Why?
Let's check this. Yes, yes, yes. Yes. And you can define also complex numbers by using the J for the imaginary part. And Boolean types, the words true and false are with capital T and with capital F are known words for and recognized words in Python. It knows what it is. So the Boolean functions are and, or, not, zor. So you have the and, or, not are so easy, and the zor is like this. And the strings, you can use for strings one quotation marks or double quotation marks, and you can know the length of the string by the function len, and you can combine strings by the plus sign. Yes, but if you want a space, you have to add that space, because space is a string also. and you can use this in a string. You can use this percent sign in order to say after that what this variable is. So it will take the variable hello and put it here. And when we say, and when we type s, Python expects a string to be here. So hello is a variable of a string, yes? And world is also a string, and 12 is a number, D for integers. And there are functions in this class called strings, yes, and these functions are called methods. If you remember, Python thinks of objects as instances of classes, and we can use for these instances of classes the functions or the methods that were defined before for these classes, yes? So we have the capitalize function or method. We have the upper, the capitalize it capitalizes the string, means it capitalizes the first letter. It makes it uppercase. And we have the upper, it makes all of them, all the letters in uppercase. We have the right justify. It moves the string to the right and adds to the left of it a number of spaces. Here it is 7. We have the center, and we can replace every substring in a string in another substring. Yes. So for example, we can replace L with ELL and with the parentheses. And we remember that when we want to call the functions or the methods defined for this class, we have to take the object or the instance, make a dot, and then use the method. Yes. Data storage or data structures, we will start with lists. So list is like an array in other programming languages, which means that the position in the list is important. It has a meaning, not like sets. And let's see. Okay. And the lists can contain different types of elements. So in one list, I can have a float number and a string, another element. The way we create lists is with brackets, yes, square brackets, and we can call an element in the string by its position. And remember that Python, the indices in Python start from 0 to n minus 1. So a list of n elements, the first element has a position of 0. Yes? And the last element has a position of n minus 1. We can call also by negative positions. It will start counting from the last. So minus 1 is the last element, the position of the last element in the list. And we can add to the list, not like tuple. If you remember, we'll talk about it in a while. It append adds an element for the list, so the list gets bigger, and we can remove or delete an element, not make it empty, but delete it. So the length of the string of the list will be -1, okay, and slicing strings. Always remember in slicing that slicing is inclusive on the first element or first index, and is exclusive on the last index. So when we write 2 to 4, it is only 2 elements. It is the element of position 2, which is the third element, up to the element of position 3, which is the fourth element. Okay. And also remember, when you slice, and for example, for instance, if you define a new string, define a new list, which is the slicing of another list, if you perform manipulations on this new list and you reassign it, it will change also the original list. Okay, so the slicing is tricky. Yeah.
You change the contents of objects in the list slice, then you change it forever. But if you change the list slice, you don't change the original list.
Yes, because I define a new variable. Yes.
Because you created.
That's because Python is dynamical, what we call. So I define the new variable again to be something else. Yes. And when we type this colon and after that we don't type anything, it goes to the last element, and if the opposite, it starts from the first element, which has position 0, and if we write nothing, it gives back the list itself. And if we type n-1 or -1, it's the same. Yes. And loops in lists are so easy. You can take any dummy index or any dummy variable that you want, and you say for animal in animals, print animal. Yes, it will runs over every element in the list. And if you want also to pull out the index with the element, you can use the function enumerate. Yes. So now you are running over the index and the animal, and you can, for example, print both of them. Okay, and we add here +1 because the positions are started to be 0, 1, 2. Manipulations in lists. If we want, for example, we can take a list, for example, and make a function of the elements of that list and define a new list. So if I want the list of the squared numbers of integers, the first 4 or 5 integers, I can define the nums to be the integers. 0 is not integer, but it's okay. It is integer, not natural. 0, 1, 2, 3, and I can define a new list to be empty and append to it x squared when I run over x in a loop. Yes, in nums. But we can define it in another way. Yes, we can say x squared for x in nums, that in one line. Yes, and we can add also a condition. For example, take only the even numbers and square them. And so that's x mod 2. If x mod 2 equals 0, equals is a condition. Yes. Dictionaries, we will not use dictionaries a lot in this course, but they are good when you write an actual code. And they are what they sound. to be. Yeah, they are. Every dictionary is somehow a list of keys and values, and we can call the value by yeah, okay. طب עכשיו. بطارية. Okay, לבריאות. Okay, so in dictionaries we can call upon an element or a value by its key, not its position like in list, but its key in dictionaries. So here we define the to be cat, the key cat and the key dog and the key fish. The cat is cute, the dog is fury, and the fish is wet. And if we call upon the key cat, it will say to us cute. Okay, so d of the cat is cute, and we can ask if the key itself exists in the dictionary. So print cat in d. This is a condition. It's or to be true or to be false, and we can get the value. And if the key does not exist in the value, we can take a default string and a default output. Yes, that's the function or the method get in the dictionary. And also we can delete a key in the dictionary, and we can add keys in the dictionary, of course. And loops, we can run over the keys in the dictionary, and we can also run over the keys and the values using the items method in dictionary. Yes, so we can define this dictionary, which has keys of animals, including humans, and the values of these keys are the number of their legs. And if we ask what is d of a person, it is 2. And we can go over all the elements by a loop for animal in this dictionary. So the animal is the key here, and we can write its legs. We can define inside the loop legs equals d of the key, the value of that key, and then print the legs and print the sentence that a person has 2 legs, a cat has 4 legs. So that will be printed. And as we can do in lists, go over the index or the position of the list using the enumerate, here we can run over the keys and the values using the method items. Yes. So it gives the same result. And I think you know these manipulations. Okay, so we can build a dictionary from a list. For example, define these nums and then define the list X, and I will go over every even X in the nums, and I define the dictionary of X and X squared. So the key here is 0, 1, 2, 3, 4. Forget that condition. 0, 1, 2, 3, 4, and the values are 0, 1, 4, 9, 16. But because of that condition, I will get this dictionary because I added the condition of being even number. Okay, sets, also sets, we will not use it a lot in this course. I don't think we'll use it because it has the problem of being not ordered. And if there is an element that exists more than one time, it will be considered as one element. Yes. So that's sets in mathematics also, and it has the problem that because of there is no specific position for an element, if you define a set using curly brackets, yes, use curly brackets for sets, and if you define that set, for example, cat and dog, and you call you try to call the cat by its position, 0, for example, it's not necessary that you get the cat because the position can be changed in sets, and you can know the length of the set, and you can ask if some element exists in that set, and you can add elements and you can remove elements. Yes. And loops in sets are like loops in lists, but again, you don't know exactly the position for each element. And I remind you that for this set, if I use animals.add cat for the animals, the set will be again itself cat and dog. Yes, because there exists a cat in the animals. Okay. Also here we can use enumerate like lists. And we can here we give an example for squared from math. We import this function square root, and we can define the set of squared numbers. But as you see, integer of squared x. So if I did not put this int, what will be the length of this set or its size? What do you think? What is range 30? What's this? Range 30. Yes, so it's 0 to 29, not to 30. And if I define this without the int here, what is the size of this set? 30. But because of the int, that's it. there are many repeated integers here, and they are only up to 5 maximum. So we have 0, 1, 2, 3, 4, 5. If I write here 37, then the 6 will appear. And as we have seen, lists are mutable. I can change lists, and tuples are not mutable. Tuples, we write them with parentheses or regular brackets, if you want to call that. And also, we will not define explicitly these tuples, but we will get them from functions. And if we define a function or method, it gets a tuple. That's okay. But other than that, we will not define tuples, but we work with them all the time because the 10 that we write 1, 0, 10 is a tuple. Python recognizes that, knows what is it, and we cannot change it. Okay. And we can use tuples to be in dictionaries, not like lists. Okay. Any questions for now? Okay. So functions, we use def to define functions. So we can say def sign of x column and then define what is this function. And we can define this with, for example, the conditional way. And if I want to run if I want to check many options for something, or if I want to make many conditions, I can use if and elif. Yes, if I don't want to exit to be out this if until I get the else. Okay. Why is it good? Why cannot I say, for example, if x bigger than 0, then return that, and that's it. And I say if x is lower than 0. Why do I use the elif? I can, but why we use the elif? What?
You don't return else, then you want to make sure that you don't check something that you already know to be false.
That's it. Yes. If it is positive, then Python will not read anything of it. Yes. So mathematically, it is equivalent, but in time or complexity considerations, it's not equivalent. Yes. It's more efficient. Yes. And okay. So okay. So and we can have arguments in the functions that are set to a default value. For example, this loud here. And if we do not make an input for this loud, it will be what we set it to be, false. And if we want to change that, we can change that when we put it. So this function called hello, it gets a name as an argument in it, and it can get another argument. If it gets it, it knows what to do with it. If loud, it is a Boolean variable. Loud is set to be false, so it goes here most of the time. But when someone changes this to be true, it goes to here. Yes. And we can add this loud equals, and we can remove it. Yes, it is sufficient to type true also. And if we want to define an analytical function, we can use the lambda function. It is much easier when we define a function of some calculation, we can say f equals lambda x. It's like f of x equals x squared plus 3. Okay, so that's the meaning of lambda. We type lambda x colon. Okay, and classes, again, every object is some instance for some class, and this class has attributes which are fields and methods, and we can initialize that with the constructor. Yes, every time we have constructor, and every method we define in the class, it has one argument, which is the self. Yes, because it calls that class, that object of the class. Okay. And now about NumPy library, we will use in this course NumPy library. Maybe we'll use I didn't check, but maybe we'll use also the SciPy library, but more important, the matplotlib. So the NumPy library is basically a library of scientific or mathematical computations. So let's talk about what's defined in it. It can deal with arrays in a much easier way than without it. So we can import it, NumPy, as. When we say as, that means that we rename that that library, so we call it by this short name, NP. So NP is NumPy. And we can define arrays. And the arrays in NumPy is very good in tensor calculations. So the array here is a tensor, and this tensor can be ranked by 1, 2, 3. You know what is rank 1 tensor and rank 2 tensor and rank 3 tensor? Yes? So for example, I can, yes. So for example, if I have some quantity called t, and it has 3 indices, and this index goes from 1 to 2. This index, okay, let's use Python, 0 to 1. This index goes from 0 to 6, and this tensor goes from 0 to 17. So this is a rank 3 tensor, okay? And its dimensions are 2, 7, 18, okay? And if we want to write it, so, well, for example, let's say that all of the values of this tensor are 0, okay? T0, 1, 3 is 0. All of them are 0. How do we write it? So we have these brackets, and inside these brackets we have two layers, let's say 1 and 2. Okay, inside every one we have 7 quantities. Okay, so inside this we have 7 quantities. Seven times. This is the 0 one, and this is the 6th one, and this is the 0. This 0 for this axis, and this 0 is for this axis. And in each, and we have the same thing here. And in each one, we have 18 elements. So here we have 18 elements. Okay, so we have 0, 0, 0 here, 0. Okay, and the matrix, what we call matrix, is a rank 2 tensor. Yes, and the vector is rank 1. Okay, so this is a vector, and if we want a column vector, the column vector is so this is a row vector, and this is a column vector. Okay, and this is of rank what? This is of rank. Okay, and what are the dimensions here? 3. Yes. Yes. And this is 3, 1. Yes, in Python we write 3 comma, because we can change that. Okay. So if we want to define an array or a tensor, we simply write mp dot array and put that array in the parentheses of the array. And we can ask what is the type of this A. It will say to us it's a NumPy array. And we can ask about the shape. The shape of it is 3, which are the dimensions. And the rank is, of course, 1. And I can print, I can call the elements by the indices. Yes. So if I want to call this 0, or let's say I want to call this 0, what I will say for it? T of what? 0, 0, 1. Yes. If I want the second 0 here.
Want to notice that this is different, different from accessing Python lists. A nested Python list requires many parentheses sequence. The parentheses, square bracket 0, square bracket 0, square bracket 1.
Ah, yes.
Yeah, if this was a nested Python list, it would look a little different.
Yes. Also, in NumPy, I can use the functions that will be defined, or that are already defined. Okay, and if the array has 2 axes, so I can call by the 2 indices, call the elements by the 2 indices. And I can build known or simple arrays by these methods. So the zeros give a matrix of a tensor of zeros, and these are the dimensions of the tensor. And ones creates with 1, and we can create with any constant we want, with full, and we can create an identity matrix here using I, and we can create a random matrix and a random tensor also, and we can also add the distribution, and always you can check the documentation. So the indices in arrays and the slicing, I think we've okay. So let's check slicing how it works. If this is an array, how do we define it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I can define it like this. And if I want the 2, 3, 6, 7, how will I slice this? So in the first axis, I will take the first and the second row, which are the 0 and the 1 in position. So it is from 0 to 2, which is from 0 to 1, because the last one will not be counted. And I will start with the second element in columns to the third, which is 1 to 3, because it's 1 to 2. And this will print, this will give the array 2, 3, 6, 7. Okay. And again, because of that slicing, if we change the elements, for example, if I reassign b01 to be a number, that number will be also changed in A in the same position. Not the z1, but the position that corresponds to that, depending how I sliced. So that's the example. And we have little differences here. Let's say that we slice in that way. We say for it column here, which means all the elements, and 1, and we slice like this 1 to 1. Yes, so it's also 1. But what is the difference? This will give me the numbers or the elements themselves, and this will give me lists of the numbers, so it will give me in the end a column vector. Yes, so these brackets were added because of 1 to 2. Okay. Okay, so how do we extract elements? So we can type the t with the indices, but also we can say, for example, if A is an array of rank 2, we can give it 2 vectors of integers. You see, 0, 1, 2, or lists of integers, 0, 1, 0. What this will give? This will give a list of A0, 0, A1, 1, and A2, 0. Okay, so A0, 0 is 1, that's the one here, and A1, 1 is 4, and A2, 0 is 5. So it will give me 1, 4, 5. So I put 2 vectors or 2 lists in that A because it's of rank 2. And the length of them is equal, and it produces for me this vector 1, 4, 5. Yes.
Like the list of, like say x coordinates and y coordinates, like imagine the pairs of this here.
Yes, but why did you call them x coordinates, y coordinates?
Like integer coordinates, right? Like say it's rank 2 thing.
Yes.
Table, right?
Yes.
It's just list of corresponding coordinates.
Yes. So this is equivalent of this. That's what I said. And it produces, when I say a vector, and it printed as a list, it's a vector. The difference is list is defined in Python, but vector, when I say vector, it's defined using the NumPy in Python. Yes, so it's an array in NumPy. And because of this, this is equivalent to np.array. Yes, and that's how we generate this array. And another example, 0, 1, 0, 1 will give me the same element 0, 1, which is 2, 2. Yes, and it's equivalent to np array A01, A01. We can also produce a vector of range. like the range. Range produces a list, yes? Range of 5 produces 0, 1, 2, 3, 4. And a range produces the same thing, but an array of that, an array of the numpy. So if we write, if that's our a matrix or an array of rank 2, and we define a vector which is 0, 2, 0, 1, and I produce an array of integers or a vector of integers, which is, in this example, it is 0, 1, 2, 3. So the np arrange 4 will give me 0, 1, 2, 3, and the b, it is 0, 2, 0, 1, and I put them in the array A. That will give me what? Will give me the 0th element and the 0th. That's what's written. It will give me the 0th element from the 0th row and the second element from the first row. The first row is the second row, yes? And it will give me the 0th element of the third row, 3, 4. 1, 2, 3. And the last one from the fourth row or the third row, call it what you want, will give me the first element. So let's see. So from the first row, that's here, 0, 1, 2, 3. It's 0, 0, and then 0, 1, 2, and then 2, 0, and then 3, 1. Okay, so the 0, 0 is 1. That's the 1. And the 1, 2 is what? That's the 1. What is the second in this? It's the third, yes. The position 2. It's 6. And from the third row, I get the 0th element, which is 7. And from the fourth or the last row, I get the first or the element with position 1, which is 11. So that's what I get. Here we have to use NP, not EG. It's a mistake. So we can add to the element 10, yes. And we can add to more than one element. These are manipulations that you will try also at home. And we can, from that array, create a Boolean array with some condition. For example, we can ask for this array which elements are bigger than 2, and we can only say A is bigger than 2. It will produce an array of trues and falses, respectively, for that for each element, and other operations in that library are done element wise. Yes, so it checks every element and produces this, and we can say to it, A of A is bigger than 2, and it will give me, I can pull out every element that is bigger than 2. Yes. Okay. So I can define this Boolean array, and if I say for it A of that Boolean array, it prints that, or in one line, I can do that. We won't talk about this a lot now, but maybe in the in recitation too. So we can, when we define an array, it again, Python chooses for it a type. So if we ask for that array, what is the type, the type in the NumPy of that array, it says to us it's integers. And we can force a type when we define the array. We can force the type, and we can write here, for example, float. Yes, even though we typed 1 and 2. And again, the arithmetic between arrays is element-wise. We can add, we can subtract, we can multiply, and when we multiply arrays, it is again a element by element. So it's not the mathematical multiplication between matrices. So we can use these signs or add the minus sign or subtract, but in NumPy. So, and when we divide, also this division is element wise. And if we want to use matrix multiplication, it is the dot function. Yes. So the dot function, it works. Let's see how it works. We can use it like this, v dot w. So this is a method defined in the array in NumPy, and we take v dot w here, but also we can take np dot numpy dot the multiplication between v and w. Both of them both of them are defined in that library. And if there are two vectors, this is the dot between them. If we have v and w vectors, this is the dot. And if there are matrices, it is the matrix multiplication. It is what you expect. Also, if it's a matrix and a vector.
Is it also for higher order matrix or
the dots? No.
Works only two matrices.
Yes.
It throws an error otherwise. Also, the size are wrong.
Yes. For other tensors, you have to define that, and you have external multiplication also.
If you out of dot product to matrices of different sizes, does it add with zeros or does it throw an error?
No, if it's with no, if the multiplication is not defined, it will be an error. And we can sum over the elements of an array, and we can sum all the elements, and we can take only one axis and sum the elements. So, for example, I can sum if I have Tij and I want T0j to be summed over the j, 0 to n minus 1, and I want the vector this is T0j, and this will be T1j summation over j, until, for example, T6j and j runs. So that's a summation over the 0th axis. So I fix the 0th axis, and I sum over other axes. If I want a Ti0 summation, the I1 summation. That's how we sum over. We call it we sum. We fix the second axis and sum over the first one. So if I put axis 0 here, so it will give me the sum of every column, because in this axis, in the outermost layer in that array, it sees two elements and it wants to sum these two elements. Okay, so this 1, 2 plus the 3, 4 will give me 4, 6. Yes. And now if I say I want the axis 1, it goes deeper and it goes here and it sums these numbers. So it is 1 plus 2 and 3 plus 4. Make sure that you understand these tensor notations. So this will give me 3 and 7. Okay. Okay, that's another example. This is the transpose. Yeah, yes. So we can use T for transpose, uppercase. And broadcasting, for your question, it doesn't work for what you have asked, but it does work for other things. So broadcasting means or allows you to make manipulations with matrices of different sizes that you naively would expect, would not expect to be able to do that. For example, this x and this vector. So this is a matrix and this is a vector. And if I ask you x plus v, what does it mean? So mathematically, it doesn't mean anything, but NumPy can understand that via the broadcasting. With some conditions, not always, but for example, for this example, here, if we duplicate this row, which is 1, 0, 1, we can duplicate it 4 times and then add that. Yes. So it understands that if you want to add a vector to a matrix, the meaning that you want is to add the vector to every row vector in the matrix. But again, you have to type a vector of length 3 here, because the length here is 3. So if we want to do that by hand, what will we do? We will create another. If we want to add, to make what I've said, we have to define another matrix with the same shape of x, but to be empty. So we call that the function, or the method of that is empty like x. And then we go over a loop, and every row of x we add to it v, and that's y. That's the ith row in y, and that's how we create y. So in NumPy, we can simply say x plus v. Okay, so this broadcasting, again, it has conditions for it to work. You can read about them, but they are intuitive. They are compatible with what we think. And sometimes to enable external multiplication, we have to reshape the matrix. Also, I think you will you have to make exercises for that to understand this. But we can reshape the matrix. For example, this matrix, I can reshape it to be 3, 1 instead of 3. And that will make it a column vector, and then make some manipulation to get an external multiplication between this vector and this. Okay. Okay, these are examples. We don't need them. Okay, the SciPy library contains for us, it contains more special functions. Yes. So you have sine function or cosine function in NumPy, but you don't have, for example, Bessel functions of the first kind or the second kind. You know them? Okay, so it has more functions defined in it for special functions. I don't think we'll use it for another thing. No. And this library is so useful for us, the matplot library. It will enable us to plot things, and it is Python is like MATLAB. You produce vectors or you produce data, and then plot that data. Yes. So also here we have to assign np dot. Okay. Huh? I don't recognize it. It's supposed to be NP. I'm pretty sure. So we can use like the range. You can also add the differences that you want. So yes. So if you type range of 3, it will give you from 0 to 3, from 0 to 2, which is 0, 1, 2. But you can write range 3 with the differences or the slicing. For example, here it will be this range will go from 0 to 3 pi. Also here we have np.pi. And it will go by steps of 0.1. And as you see, np.sign of x, which is numpy.sign, the method sign defined in the np library, and we perform it over this vector, and it gives a vector. So it is, again, element-wise. And we can plot using the PLT library. We call that library PLT. Using the PLT library, we can plot the vector x with the vector y. So that's the sign function. And we will show that. Yes, here we make the plot, but if we want to see it on the screen, we have to add this dot show, and we can also add other things to add to the plot. For example, I can define x, I can define the y sign array or vector and the y cosine vector, and then I say for it, plot the x and y sign, and plot the vector x and the y cosine, and plot. Here is a method, which is the x label. It adds a label for the horizontal axis, and another function or method, and another method, which is the title, and another method, which is the legend, and I can call the legends whatever I want. And then I say to it, show me, and that's yeah.
the show like that only works in Jupyter, right? If you just write a Python file, you have to write it to
Yes.
an image file.
Yes.
Oh,
Yes, but it will be that's it. And we can also plot subplots. So we will use the subplot method, and we tell it how many subplots we have, and we tell it how, where to put them, the places. So this is the first subplot, and this is the second subplot. And after that, we say show, and that's what we get. Okay. And again, if you want to debug in Jupyter, you can read about this more here. If you want to debug, you can type %sign and debug, and it will help you most of the times for debugging. I prefer for you to use Google, because in other languages it may not be something like that, and it's good to know how to Google these problems that arise when coding, and know how to debug them using other advice from other people. Okay, so I think we finished early. That's good. So that's it. Any questions? So you will have exercise 1. It's already uploaded to the Moodle. You have 1 week for that, to Friday. And on Tuesday, we will have another exercise, and also it has only 1 week. Okay, so and this exercise is only programming. That's it. Okay, see you. I'm sorry if it was boring. It was boring. I'm sorry. I think the next exercises or recitations will be more interesting. See you.